My name's John. My colleague Ram in the back there is actually the guy who did all the actual hard work, right, in building this. Cloudtalk is a web app that's a platform as a service. We deliver social communications, so basically MIME messaging and conversations, right, between one-on-one or one-to-many people, public and private. Lots of cool stuff going on. It's very scalable. It has SDKs for things like mobile devices and the web. And more important, it's got this need for a very scalable data store, which is why we're here to talk about this. And this is just another slide. I mean, again, it's all about building out a scalable data center. Why NoSQL, Cassandra, and what were our objectives? Well, we were on a simple DB footing with Memcached in Amazon, and it was killing us, right? And we were not happy campers. We did not want to be tied to Amazon's services, because let's say we wanted to go to some other cloud or build a physical data center, which is actually what we ended up doing. We wanted faster and cheaper, and we'd rather solve a data model. So that's why we wanted to get out and into something like Cassandra or some other NoSQL solution. We looked at a lot of stuff, right? We ended up with Cassandra, and what we realized is we'd rather solve the data modeling problem than the problem of sharding and scaling. And that pretty much kept us way clear of anything that even smacked of SQL, right? And so what we're going to just tell you about briefly is what we actually did in terms of having to get an application, to sit on, a NoSQL database. This, we thought was going to be a lot easier than it was, right? There are no object or relational mapping analogs really in the NoSQL world. And we were looking for a DB that could manage almost all of our data. So we didn't want to have to get Cassandra and Redis or Cassandra and something else. And Cassandra actually had the best chance of doing that. We ended up using it on top of Solar, or underneath Solar rather. We used it for a queuing system, and we used it for our application data. And I just wanted to point out a couple things we had to build here. So in our data model, we have social constructs like communities. Go ahead.
Question on the previous slide. So what was it that was bad about SimpleDB? I mean, I just haven't met.
SimpleDB, okay, so where can I start? A, it's really, really expensive. B, it's got a limit to the number of columns you can have. C, the largest database you can have is 10 gigabytes.
Oh.
You can go on and on and on. It's a very unhappy place to be. And it's simple, right? Yes, they weren't kidding. It's not Dynamo. It's SimpleDB. It's not the same thing, right? But the only thing going for it was probably written in Erlang, so you can yay, cool language. So we have a bunch of application constructs, which are what you'd expect in a real world web app. We have communities with all sorts of people and access control lists, and we've got social networks and social graphs where arcs are named, and the source of the arc is important, right? And then we have this whole conversational messaging mechanism, which is that conversations are things between one or more people or in groups, and that messages are streamed through time. They're basically feeds, and these are MIME messages, so there's a lot of information to keep there, right? And so we wanted to build a system that could do this justice, and we ended up that we found out in starting this whole thing that you just couldn't just dump a bunch of data into a NoSQL database. You had to find some analog to the way you were used to doing business, which is you needed to find some sort of way to map objects into your data store. Now, in our case, Cassandra, but in a database where documents are the way things are stored, it's a little bit simpler to understand how that's going to happen. You're going to take your piece of JSON and you're just going to dump it into your database, and you're going to be happy, and it's going to get indexed. We had access patterns that wouldn't allow us to choose a database, right? Document style database. It just wasn't going to work for us, right? We knew that some of our constructs were very tabular. Doing a social graph the way we needed to do it just wasn't going to be a document. So we ended up having to build our own data definition and data manipulation languages. Ram can tell you a lot about that. We ended up having to build automated indexing. So our model had a lot of semantic awareness about it, that certain things have to be indexed. Those indexes are built for you automatically so that you can now find things. This goes to the gentleman's question about how he finds stuff. We had to build that into the system. We had to build in transactions, right? Because programmers are used to having this concept of transactions, and and they have to work in a way that's sort of similar to the way that they're used to doing business. And then we ourselves had to build a queuing system. We looked at a lot of the queuing systems that are out there. Just a sec, Patricio. And we ended up building our own, and that turned out to be one of the harder things we had to build. Okay, Patricio first.
Just if you could provide more details about the transaction layer that you built.
All right, Vram, I'm going to let Vram, you should come up here so you can be in front of the camera. So,
In particular, what type of transactions are like?
So let me add one thing why we didn't like
how
simple
many
DB.
processes or-
When we use simple DB, we end up charging a lot since we had these 10 gig tables size, and at the end we had to do all those putting the queries back by ourselves, so we end up in a very big mess. So unless you have something very small, never use simple DB. So the first thing we wanted to do in Cassandra, we were using Amazon, so we wanted to take everything from Amazon and move it. So we were using the computing environment, we were using SQS, we were using S3, and we were using simple DB. So for S3, luckily we were using Fuse as an interface, so we didn't have to be really tied to S3 interface, so it was easier to move. Now we had the issue of SQS. We like SQS a lot. It's fantastic what it provides us in a distributed environment. So we wanted to build something on top of Cassandra SQS, and we wanted to take some of the ideas of the simple, we wanted to make Cassandra easier for us to use. So the first thing we wanted to do is say, let's define our data DDL. So what we did, we took the objects, as we said, any object can have, in general, 3 types of attributes. Some static, some semi-dynamic, and some of them are dynamic. Static attributes, when you get an object, it's basically said, you might need them. So we access them all at the same time when we're loading an object into memory. Semi-dynamic objects, we didn't like the concept in Cassandra. I guess right now people start calling it composite attributes. So we wanted to build those ourselves. So we built paths. So it's a path we specify during the DDL. We say, okay, you can have, let's say, email dot start, which could be the email address, dot something. So we defined our own complete paths, and we defined it through the DDL, and we gave it a type system. And runtime, those starts, we can substitute them in runtime. So that's why we had defined our own path language. So we took the column names and we defined them over paths. And that way we can have an infinite number of nested objects built on top of Cassandra. So that was our DDL. And on top of it, we define our DML, basically. When we want to access Cassandra object, how to access it. You asked the question how we did the transaction. So what we said, okay, we start a transaction, and we end the transaction. And there is something very nice in Cassandra. You specify your time. You want to timestamp everything at the same time. So those transactions can be over the same column family or multiple column families. So we take them ourselves, we divide them into, we batch them, and then we commit them. At the same time, we keep the whole transaction ourselves. We have the whole history of the transaction. If it fails, since we have the time, we can run it again and again and again. So we kept this ourselves so that if we want it, we can run everything again. And since it's a history base, it's time-based.
Do you also keep it in Cassandra?
We can keep it in Cassandra. So all this is kept in Cassandra. And besides that, we kept everything also, everything we denormalize it. We denormalize it very heavily. In addition to that, we keep everything as a time period. Every operation that we did, we kept it as a time period in different tables, so that later in the future we can replay them. And those time periods, we kept them for, per second, we created new row per type of operation. So we kept history of all the operations that we had. So we had our operational database, we had our history database, and we have our transactions. So we had huge amount of the replic data. So we can create and play everywhere we wanted to do. For everything we created, for every object we created one-to-one concepts, and we create one-to-many. So for instance, a person can have many emails. So those email addresses, we point them back automatically. We can say, okay, those are one-to-one, one-to-many. We created all this in our data definition language. So we kept all this automatically. Users don't have to do it any work. So we did all this thing. So we can have one-to-one, one-to-many relationship. And that's how we kept also our all graphs and relationships
So you talked about this language, so you guys built your own mapper, basically?
Yes, we built our thing on top of Cassandra. So the last thing we did also, we wanted to implement SQS on top of Cassandra. So SQS has this very nice concept of leasing. So we want to implement this concept of leasing. So the way we did is basically very simple. We lease. You can lease an object. You say, I want an object. I want to work. Leasing. I want to work on an object for an hour. After I'm done with it, if I haven't finished it in an hour and I haven't deleted it, the object goes back to the queue. If I'm done with it and I finished it, I can delete it. So we wanted to implement this concept on top of Cassandra. So
And that's why, and you're talking about SQS, you're talking about Amazon SQS?
yes,
Yeah,
Amazon
simple
SQS, yes.
queuing
So you're
service.
mixing, it's kind of a hybrid cloud type thing.
Yeah, so we implemented that on top of Cassandra. So we said you can specify, you can create your queue. A queue is basically just a row. The name of the queue is the key, and the elements are the columns. So you want to lock it. We implemented our own way of locking it. I can explain it. It's quite I can simplify it. I say I want to lock. I want to read an element from the queue. I read it. If I find out that it has a timestamp in the future, I know that somebody else is using it. If it doesn't have a timestamp, or the timestamp in the past, it means somebody has used it and they didn't delete it, which means they have died or they haven't completed the job. So I said, okay, now I want to lock this object. So I create another column, which I take the timestamp that I have, add 1 to it, and I write it. And I put there my own identifier. Then I read it back. If I get the same identifier, it means that object belongs to me. I can go back and lease it. So that's why we implemented some type of SQS on top of Cassandra.
Cool, very good. All right, well, just in the interest of giving folks an opportunity to ask questions and have a discussion,
Sure,
would
go ahead.
that be
Yeah,
a good time to do that?
Yeah.
I think what we wanted to get from folks is a sense of what kind of challenges have they had in building like a general purpose web app. Now, there's services, like this queuing service is very specific, and you can go to Twitter and they have a geo service built on Cassandra, and it's very nice. And building very specific services that have one point, one purpose in life seemed to be, to us, to be a simpler challenge. When we actually tried to go a little bit more broadly to build a general service web app, we found that the challenges expanded much more quickly than we expected.
I'm really, it's refreshing to hear you guys say that, quite frankly, because sometimes in the Valley or in the Silicon Valley, if you say something like that, like, how do you build a web app on top of NoSQL database? Some people will kind of look at you like, well, why are you asking such a dumb question? But the reality is that that's probably what a lot of people are asking. They just have not.
And there are many solutions. Like if you listen to the guys from Twitter, they have this wonderful way of just like throwing updates into a row and then like left folding over the entire row and coming up with the right answer. But that doesn't work for every application, out there, and especially applications that are very object oriented. Like I'm going to transact this object right now and I want to put it back, right? And so these are different challenges. And a relational database and all of the tools that have been developed over 20 some odd years are really good at that particular model, that use case. And NoSQL databases aren't yet as good, but there's a lot of benefits. I mean, these mothers are fast as hell, right? I mean, everybody who's used one, I'm sure, has that same experience. They scale really easily. I mean, you just plug a new node in the Cassandra case anyway, and it just plugs in and balances itself, and a little bit later, everything's happy again.
Yeah.
Right? So there are a lot of benefits, and we wanted, knowing that we were basically building a cloud service, that was part of our thing. Scalability and ease in that sense was very important to us. But it came at a cost, right? You have to build your own object NoSQL mapping layer. We're still struggling with that, right? We aren't there yet, right? And I think one of the things we'd like to know is like how many other people have even tried this, right? And if you haven't and you're interested, would you like to try it with us? Because one of the things we'd like to do is open source that layer, right? We don't want to own that whole thing. We want to throw it out there and let other people, like, you know, at least take a look.
So you're using this now just for your service, or have you done this for other people?
Well, it's running in our service. We aren't, I mean, you know, if I said to Vron, let's like throw it in GitHub today, he'd probably like recoil, like it's not ready. But that's kind of always the way it is, right?
Yeah.
But we'd like to do that.
That's
and-
about
and-
when it's ready.
Right, and we'd like to get other people involved. You know, quite frankly, there's no like description language. You just write a file of code that looks kind of like a description language. It's very hard coded at this point. We'd like somebody to come in and, you know, even we could discuss like what would it be a viable description language for what we've done. You know, should we invent our own syntax, use something that exists already? We don't know because we haven't gotten to the point where people are jumping in. But we know that we ourselves don't have the kind of horsepower, and this is the whole point of open source, to just like invent the world in this sense. And
Now, do you have a name for it?
actually, Pelops is what these
We
guys.
use Pelops, but
he got like usurped.
yes, we used Pelops before Pelops was out internally, but somebody else took it.
So he needs another Greek name. So anyone who has a quality
thought
Greek
about
mythology reference.
Combining the two Pelops and there is the other one, we combined them together, made it Telops.
All right, well, cool, well, thank
So,
you.
questions?
Does anybody have any questions for them? Yeah. Okay.
Yeah, I do. So can you talk a little bit about the indexing? So it looks like you just did the equivalent of foreign key indexes, basically. Is that, you know, I see this, where you're building index so that common queries
So,
are gonna actually have an index there.
so
they
a
can
lot
push
of
it.
things we did since we started on top of Cassandra 0.5. Right now, Cassandra 0.8, and we're going to 1.0. So a lot of the things we did, Cassandra wasn't ready for us yet. So we couldn't wait for Cassandra. We wanted to have our app out. So that's what we did basically. The automatic indexing is basically, we built, but we define it, you define it in your DOM when you're defining your DDL that you want to index those and you want to implement one-to-many. So.
Did you find you had to tweak the indexes a lot as the application, as the amount of data in Cassandra grew, or did you change the application?
Not that, I mean, what we find that the toughest challenge was for us is Cassandra forced you to do a lot of the normalization. So we had to understand the whole, you have to have an idea of what you want to answer from the beginning
Right.
before you design. So that's one of the challenges in implementing. So you have to denormalize. And we did a lot of denormalization. We had no other choice to be able to do it. And some of the things, if we do it today, we do it differently. Most probably SQS. If I do it today, I will do it differently. I will use some ideas the way Solandra was done finally, which means go to the Cassandra side and implement it the way that Solandra is implemented. So we implemented as a client. We could have done completely on the server side. And it could have been much faster.
Yeah, stored procedures in
Yep.
Cassandra land would be really, really helpful. That's one of the things. So you end up learning that the solutions that somebody did like a long time ago were probably pretty good solutions. So one of the things that you'll find, especially in the Cassandra world, I don't know about too many of the other databases, is that since you don't have server-side computation working for you, you have to do everything on the client side. So you can't build a piece of code that sits right on top of the database, right, and does work for you. You have to bring all the data out, right, through Thrift, you know, just shoot me now, right, get it into a client, and then manipulate it, right, and then push an answer or some transformation back. A lot of this stuff, you know, if you had some concept like stored procedures sitting on top of, you know, your Cassandra cluster, would really make our lives a lot easier.
Thrift as in Facebook's Thrift?
Yeah, that's what's used, and there's a lot of movement going towards, you know, native drivers, right? And that's another thing that we didn't have the opportunity to take advantage of because they just didn't exist. I mean, so things like, you know, counters weren't there, so we had to implement a mechanism to do counting. That turned out to be very difficult, especially, you know, when you have multiple clients all coming in asynchronously trying to update the same thing. Blocking is not something that's native to these most of these databases, right? The idea of, you know, just, you know, as I said, being able to do stuff on the server side rather than the client side would have saved us an awful lot of, you know, just dark times. I mean, you know, early Cassandra and all the things we were trying to do, you know, and we weren't the only ones. just trying to keep the ring from like just, you know, spinning out of control, right, at any given point in time was very difficult. Now, today, a lot of these issues are being addressed, right, and what we'd like to do is at the application layer and the service layer is just say, hey, what kind of problems, you know, are common, and what can we do to contribute to the community in terms of offering up solutions to things like queuing systems, et cetera.
A lot of our initial problems also end up, since we highly denormalized, in some cases, if you want to update column family, we had to update 20 or 30 other tables. So we wanted to have so much denormalization. So if we have implemented our own triggers, life would have been much more easier for us. We didn't have time to do that.
So it seems like you're thinking of the social space a lot, what
Mhm.
you're doing, and the reason I asked that question is you've done things for other people. Facebook just announced their timeline thing that's just about to roll out, so I'm wondering if they're using Cassandra, because when you're talking about these timestamps, you're thinking, gee, that maps really nicely to something.
Yeah, I don't know the answer to that question. I do know they use it for search, you know, on their timeline. That's what the original application was, and we've heard, you know, from folks there that they use it in some of their analytics clusters. But they also use HBase for like their messaging mechanism, because they had some issues with consistency, which early Cassandra, that's probably, you know, a realistic, you know, issue. You know, Cassandra's a database where you can dial consistency in. I think one of the earlier speakers was talking about the CAP theorem. And that was one of the things, quite frankly, we liked about Cassandra, because you could tweak the parameters to get more or less consistency. So we actually run a separate cluster for the queuing system, and we run it configured completely differently from the application system, because they're just immiscible. You couldn't run these two clusters, or these two services on the same, you know, configured cluster. You'd go insane trying. So, you know, I think that these are some of the issues, you know, we're hoping to bring out. You know, we'd like to start a great conversation about is what are some of these application issues, right? From finding your data, right, to, you know, building services like queues, to just doing things like, you know, object mapping layers, right? You know, we don't have all the answers, but, you know, we have found a lot of the questions.
Well, what's stopping you from open sourcing it at this point? If you lose business value if you did that?
No, there's no, it would do us more value to open source it. It's just a matter of Vrom finding time to take that piece of code out, put it into, documenting
no
it.
documentation.
Their time is, it's the business issue is him having time to do it more than anything else. I mean, we'll probably throw it out there, and if people are interested, please contact us, and, you know, we'd be happy to have other people using it, right? But it's not like it's any other piece of software. There's going to be a learning curve, and you have to figure out, like, what the hell were we thinking when we put it together. But it's pretty cool, right? And we think that there's, if not in its current incarnation, because the current incarnation is like, you know, 0.1, but, you know, the ideas we think are pretty useful, and could be, you know, something that could you know, move forward, you know, with some support in the community.
So, well, thank you. I think that was very interesting. And what I'd like to do before we wrap things up is I want to get folks to share what other types of questions or problems that they've run into, if anybody has anything to share. Anybody out here want to volunteer a scenario or an application challenge?
Yeah, I mean, we'd love to hear what other people's challenges have been. Remember, we're a social communications platform. We haven't solved a lot of other problems. Just a question about, not quite about scaling, but more about just developer, your users, your developers, when they need to make a change to the data structure. Do you guys have a process for that? Yeah. Well,
You don't understand what I'm talking about?
No, and it's a people-oriented process. So there are two people who worked on basically the data layer, if you will, and then the application sitting on top of the data layer. One was Ram, and another is a guy named Scott McCarty, who works with us. And to make a change, right, you have to, learn how to add a new domain object to our space. And then once you've added that new domain object, you then have to create some methods on the service layer that manage that object, And then if it's going to be exposed to the web world, right, you write a web layer on top of that. So it's really this 3-layer architecture that these guys have. So the process is usually, here's what I want to do, here's my spec, and then they sit down with From, and then they bang it out.
Well, I
Right.
asked because I remember somebody was telling me that one of the reasons they thought NoSQL databases were becoming so popular was because you could get around the DBA.
Oh, that's a different issue, right? So a lot of folks, so this is the old schema update, right? Let's escape from the tyranny of schemas, right? I'm going to change something in my database, and database administrator goes like, hell you are. Well, in the Cassandra world at least, right, there are very few constraints. I can just add an extra 100 columns to that row, right? And any row, not all rows, just any row. And I don't pay a real penalty. But where you are going to pay the price is in your management layer, right? So whatever, the code that Vom wrote in PellOps, right, or whatever we end up calling it, is actually where that complexity is managed, right? We don't have to worry. This is one of the reasons that pushed us towards the Cassandra specifically, is the idea that we could just throw out as many columns as we wanted, and Vom could give you the details of how he mapped. He was talking about using paths and how he used essentially compound column names to map that out, right? That's where that complexity is, right? So, yeah, I don't have to worry about a DBA telling me I can't do it, but this guy now becomes the gatekeeper, right? Or until the PellOps layer becomes sufficiently smart enough to manage that so that you don't kill yourself in the process of trying to add stuff. That's where that complexity goes. Complexity never disappears, right? What you do is you remove the administrator as the gatekeeper, and you move that up to the level of the developers, but we haven't solved the problem to the point where he's out of the loop, and we'd love him to be out of the loop.
Well, and I asked that particular question because if you do, if that is true, that when you want to add, extra columns, you can. To me, it seems like that leads to the problem where you end up not knowing what data's in the database.
This is exactly where we arrived. This is exactly what happened. Well, most of the time, people add everything in the DB. It's really.
But can I ask you? So when the programmer added data, what was the process that your programmers use to add extra columns?
They need to add data. Let's say we have two issues. We have, let's say, we need to add metadata, let's say, to our stuff, and maybe a customer is asking for different specific AI. But sometimes we use Cassandra also to store different, let's say, version of the same object that we adapt for different, for example, mobile devices. And sometimes what happens that Cassandra is so fast, because SQL is completely fast, that maybe sometimes they just did a small JPEG for another file, they don't compress it in the right way, maybe it turns out to be bigger than the one that was stored at the beginning. And we end up, let's say, discovering this only when the system died, basically, because you don't really have a very easy way to understanding where are the data, what are the slow query. Sometimes the query are actually fast, but the data transfer of all the stuff that you have in a row is huge. So actually we have seen, for example, that sometimes we understand that something was wrong, not in the CPU or in the memory usage of Cassandra, but in the network traffic usage of the servers, because we see that there was, let's say, too much traffic, basically. There were not so much data in the database. Maybe we were moving the whole data set up and down from the front end to the back end multiple times.
I'm hearing like there's at least two issues that you're dealing with, right? One was, right, you don't have a formal description of what's in your database, and that's what Vom and Scott had built, right? And the reason we took that much time and effort, and believe me, as the CTO, talking to the marketing guy and the CEO, why it's taking so much time to build this, right? You just have to sit there and, because they don't know, they don't get it, right? They just think that you told me I could just put data in this database, and by golly, that's what I want you to do. But we spent the time building that because if you don't know what's in your database. And you don't know what format it's in, even worse, right? And if you don't build some sort of layer that manages the semantics of your application, right, you're doomed, right? So all of that investment is still necessary. One thing is true, you can just put stuff in so easily. I mean, you can, just like the wind, right?
So does your management layer let the user inspect things to see if those extra columns have been added? I didn't hear you.
So we did everything through DDL. That's what's helped us. So basically, we constrained ourselves to using a DDL, and we use the type system. So everything we typed ourselves. So every column name, we typed it. So that way, we know all this relationship, everything we define in the DDL. So it's basically, we did it programmatically. You have to reach the DL, which was separate program. It was basically, okay, this is how I'm defining my database. And on top of it, we implement our DML. Our DDL didn't turn out to be as terrific. I mean, we had time, we could have done a better job, but that way we know what's out there. And the other thing we did, we had this concept of, in addition of writing those into those tables, at the same time, we're going to keep also this window system. Okay, I have on this user, I'm doing ads. So I'm going to, every operation I'm going to do it, I'm going to keep also in the database, in completely separate tables. I type what I'm adding, my type of operation, that I have a history of everything I'm doing, that I can go back and I can run that history. So we know everything that's happening in the system.
It reminds me a little bit, and I know I'm going to be off here, but like, you know, with either late binding or dynamic programming languages, you can kind of just put whatever you want in the app. Any words you want, any language, you can put junk in there, and then when you try to run it, that's when it blows up on you.
Ruby does that.
Yeah, most of the dynamic programming languages do that, right? And it's kind of what's happening here is you can put whatever you want in the database, but then it's when you go apply your, you know, your kind of schema or whatever you want to call it. What do you call it?
Well,
Description language.
Yeah, data description language.
Data description language. On top of that, that's when it would like.
Right now, life is becoming much easier on top of Cassandra.
I'm sorry?
I understood that they apply the schema only to the data, right? So,
Yes.
So you don't mess up.
Yes.
Right, so-
But the question is, like, how do you enforce that data? Like, okay, you have your own schema, but how you can define your type?
So we'd use it our own DML, which is
When do you enforce the type?
during runtime, we find out if there is we generate exceptions,
Right.
basically.
So,
Which is what you do with a dynamic programming
Yes.
language. That's kind of where I'm.
So-
Well,
I see your point
but-
too. It's both
Yeah,
ways.
yeah.
but right now, the way our system's configured, the schemas are known a priori.
A priori.
And yeah, so we're not yet allowing people to just change a schema on the fly. Now, could we do that? I suppose we could, but then you're just gonna get into the same issues that you guys are just bringing up. I think the interesting point, and I think it's a good point, and I'm gonna make it again, is that things like schemas are good, right? They have real value. Now, who gets to manage that schema is really what gets people's, you know, pants in a twist, right? It's like the programmer should be completely in control of that schema, right? The designer, not some administrator. And what these solutions allow us to do is bring that accountability up to the level of the guy who's writing the programs and not like leave
It
it
was
stuck.
more than a schema. It's a schema, it's an access pattern. How you access the attributes of those objects.
And the
Some
semantics.
attributes, you always need them. So whenever you access this object, for instance, I want to get the name of the object, I'm asking at the same time let me know also the last name. So those you need them together. So it's what's an access pattern also. You can specify those attributes, load them together in memory.
It'd be kind of nice if when a developer, like
And-
when somebody wants to go and change something, they can. But are you saying that there's like a history or a
Yeah.
version control kind of thing?
Once you learn how to use the data description language that Vrom created, anyone can go in there and add something to our system. So what I think that Vrom's saying is that the value adds, yeah, you, me, even, Vrom would even let me do it if I took, his little course, right? So the issue I think that's more important is that there's actually semantics, embedded in what Vrom's created, as he said. One of them is just access patterns, right? This idea that there are some things that are always accessed together. Some of them, can be dynamically specified, right, at runtime, and some only come in based on, very explicit statements that you make, right, are an access pattern. But you can also have semantics that, referential integrity is another idea that's not a bad idea. It's just how do you enforce it and where do you enforce it? So you can enforce things like referential integrity, in our layer, right, if you want to do it. If you don't need it, then you don't, right? Well, the mapping is one of the things that Vrom added, this idea of automatically creating indexes on the fly as you go was an idea we realized we needed indexing, right? And it had to be done. And the data description language specifies, right, that we're going to index these objects and, what the foreign key relationships are, for
So
example.
there are certain concepts that we're going to drop it since Cassandra does right now a better job than us. for instance, the counters, when we move to 0.8, we're going to drop our counters. We're going to use Cassandra counters. I think in the indexing concept, we're not going to drop it yet. Cassandra, it's not there where we want it yet. The composite in SQL is not as powerful as what we're doing, so we're not going to drop it. So once Cassandra, I think in a year or something, reaches those concepts, you can drop them at a time. I mean, it's better for Cassandra to solve those problems or the community than for us to do it.
So which problems are better for Cassandra not to solve?
I mean, it's the community around it. Everybody's trying, adding ideas, and Cassandra becoming it easier and easier to use.
Sure.
I mean, when we started, it wasn't as easy to use, but right now it has changed dramatically. It's much, I mean.
I think there's some issues that are basic database issues, right? An ODBC like driver, awesome. When it gets there and it's fast and it's pretty universal, as Ram said, we'll probably adopt it. Indexing that works the way people want it to, right? It's close, but it's not quite there. Automate backups for me, right? Be able to deal with rolling backups while the thing's still hot. I mean, all these types of things. I know Cassandra and the community have already solved a lot of the problems, and part of that community is DataStax. I'll give them a little shout out right now. These guys know their stuff, right, and have really helped us personally, and I think are contributing from the point of view of what do I need to have a database do on a day-to-day basis, right, that's going to make my life better. Now, things that I wouldn't want it to necessarily do at this time, especially given how much in flux this idea is a data description language until we know as a community what that has to be, right? I think we're probably years off from really understanding what a mapping layer should be. If any of you guys, some of you guys look like you old enough like Brahm and me to know how many times people tried to do object relational mapping layers before, even one of them was even remotely good, right? And so I expect the same thing's going to happen, in this, arena as well.
You should name your layer after a Greek lawgiver,
Yeah.
like Solon. It's shorter than Pelops, or like Argus.
Cool. Thanks. So we got something, of real value here.
Solon is the name.
Solon? All right.
Yeah.
But I did that answer your question?
Yeah.
Okay.
Well, you said you answered the opposite side of it, which was what should the database do?
Yeah, well, what
I was
I don't
asking-
think they should do is try to too early get into the DDL stuff, because I think that's a format for quite a long time. Things like queuing systems, I know that DataStax has tried to bring in other tools like Hadoop, via their Brisk product, and that's them as a company. I think, but Cassandra, let's just stick to the basics. I need a database with a pretty decent querying language. It should be able to back itself up, right, and do all the things that I think database should be. In the NoSQL world, it's some different things than it is in the SQL world.
Sure.
Right.
It sounds like you want some form of server-side procedures.
That's one. Yeah. So,
Yeah.
thank you for reminding me.
Yeah,
The
'cause
server-side procedures would be awesome.
Because in addition to, adding complexity to the apps, it just seems like it must really kill performance for some things.
That network traffic, so the gentleman in the back that was mentioning the network traffic, absolutely a killer, right? So you have to know how much data you're asking for, and you also have to understand what happens when you put data in, because these things all start chattering, they gossip,
Right.
and try to harmonize depending on your replication level, which is another awesome thing about NoSQL databases if you're using it. This automatic replicating, so we use a replication factor of 3. So it means as soon as it hits the first node, it's got to be copied to 2 others, and that causes network traffic. So you end up with lots of issues like that, exactly.
Anybody left here from Couchbase? Yeah. I was just wondering. I'm trying to in my head understand the difference between like Couchbase and Cassandra.
We're no real experts, but I'll when you say document, think of a piece of JSON that's structured, and so you've got some sort of transitive closure of all sorts of objects in a tree, and it's going to store that for you. I mean, it's just going to put
That's
that
what
whole
Cassandra
sucker
does.
in. No, it's Couchbase. It's going to
Oh,
put that
okay.
whole sucker in the data and all sorts of things like it, and then figure out what are the things that are common between each one of these documents. And it's going to index them, right? And that's very cool. But if your data isn't that arbitrary,
Right.
right, or you're document oriented, arbitrary is probably a poor choice of words, then it doesn't help you much. Now, if you have data where you have something that kind of looks like a table, right, and you really are going to you need denormalized tables, so you may have an array that goes here, and you just don't know what the specifications are, right? there, like something like Cassandra works really well for you as a transitional type of data store. Where it's really, really interesting is when you start to take advantage of the fact that they're really, it's column oriented. I mean, you can just go out to here, not infinity, but I mean,
Right.
an awful large number of columns and start to store really interesting data in a really interesting way. I mean, think of it as a feed. You could have one row that's just a data feed coming
Right.
in, telemetry from some sort of sensor,
Right.
right? And people do that all the time. I can't remember the name of the guys in
By the
Colorado,
way,
but
this is our note telling us it's time to go.
they do that, exactly that. They take in telemetry from sensors and disk drives and
Real-time chat.
real. Well, you can do real time. There's any number of applications.
Yeah, for sure. I'll swing by there again and check it out.
Oh, thanks.
Thanks.
Thanks for sticking around.
Hey,
That's what the name of the product was.